So, hello everyone, welcome. Thank you for attending our talk. Today we'll present some of the biggest challenges as we see it in the cybersecurity world in the upcoming years and also currently, and our solution for that, which is teaching cybersecurity among teenagers and creating the next generation of security experts. So let's start off with a regular presentation disclaimer. None of the views, opinions, or things we will present you today are in any way related to our employer, any organization or something. This is only our views. So who are we? My name is Nachman Hayat. I'm from Israel. I'm a security researcher at Resilion. I used to be a security researcher at Aqua Security, which also presented here today, yesterday in the Arsenal. I also been a security researcher at PayPal. I'm the founder and also part of a security group called Nuxal, based in Israel, composed only of teenagers. We'll speak about it later. And I am 18 years old.
Hello everyone, my name is Shlomi. By the way, in case that the presentation will stop working, we will continue. Yeah. It's just a challenge. So my name is Shlomi. I'm currently the CTO and co-founder of a new startup in Israel called Resilion. Prior to that, I was the CTO and co-founder of a company called Cyactive that was acquired by PayPal in 2015. Also, I'm a PhD candidate at the TAU Tel Aviv University, focused on cybersecurity and education. And above all in that, I'm a proud father and husband. Here is the outline of our talk. I'm not going to go over each one of them. I will give you a broader understanding, and of course, we'll going to go deep into all of them. So we'll start with the growing need for cybersecurity experts among the industry. After that, we will detail the current educational system. After that, we were going to detail the problem that we have today with the current solutions, and we will suggest our own opinions and our own solution for that problem. And to showcase that and demonstrate, we will show a couple of implementation regarding our solution that is being conducted in Israel.
Great. So let's start with an introduction. Today, this is a graph showing the US need of computing jobs. By 2020, there will be missing 1 million computing jobs in the US. This number globally is 85 million by 2030, and this is 8.5 trillion opportunity. $1 trillion opportunity worth of unrealized annual revenue. If we look at the fast-growing need of cybersecurity jobs, we can see that the rate that cybersecurity positions are growing is 3 times as much as the IT need for workers. And a study conducted by Frost and Sullivan forecasted that in 2015, there will be a 1.5 worker shortage. This forecast already been revised for 1.8 million by 2022, and other studies say that it will be also 2 million by 2022. If we look at what the security workers think, we see that 60% globally of security workers think that there aren't enough cybersecurity workers in their departments. If we see the main reasons for that, most of them, half of them say that the main reason for that is that qualified personnel is difficult to find, and that there is not enough qualified personnel in their departments. Now, because we'll speak a little bit about Israel in this talk, we'll demonstrate using examples from Israel. Let me introduce a little bit about Israel. So Israel is the world's second exporter of cybersecurity, and thus it leads the employer demand for cybersecurity. So we have a big issue in Israel. We need to tackle this issue, find security experts and evolve them from nothing. If we look at the employer demand in Israel, we see that per million positions, occupied and unoccupied, there is 5,000 occupied and unoccupied job demand for cybersecurity talent. So this is a big figure. It's much bigger than any country in the world. More than the US, which is the first largest exporter of cybersecurity. If we look at the main characteristics of cybersecurity experts, some of you also have these characteristics. It is composed of three. First is thinking outside of the box. Thinking outside of the box means innovation, means thinking differently than others, than other people in your company and outside of your company. The second one is adversarial thinking, which means know or predict how the enemy will work, how the enemy will attack your systems. Basically, what it means is that you know, or security experts should know, how a code can break, especially a code in their systems, and tools predict how they can tackle these issues or potential issues. The third one is technical knowledge. Each good security expert or an expert should have broad technical knowledge in many fields such as networking, forensics, and etc., etc. And another very important rule, as you can see here on the shorts we made for this event that we will give away later, there is the 10,000 hours rule. Gladwell, in his book, Outliers, the Story of Success, said that the key to achieving world-class expertise in any skill is practicing and experiencing for a total of around 10,000 hours. This sentence has two meanings for us. First is that we believe that each one of you, and that's one of the messages we want to deliver in this talk, each one of you and each person in the world should practice and experience as much as he can in order to become an expert and every day learn something new. We'll speak about it also later. And the second one is that every cybersecurity expert should experience and learn a lot and have a lot of experience in the industry before he actually becomes an expert in something.
Okay, so after we talked a little bit about the growing demand, let's talk a little bit about the current cybersecurity education landscape. Here you can see a templated educational landscape. I'm not going to detail it now, but please remember that we are going to visit it again when we will talk about the solution. When examining the computer science education for teenagers, it's mostly starting at the high school. And if you will look and try to categorize what are the topics in which those teenagers are learning, you can see programming, algorithmic thinking, data structures, state machines, and more. But cybersecurity, deep knowledge is missing. If you will try to cluster the landscape of the cybersecurity education, we can find that there are three main clusters that can be created. The first one, academia. The second one, industry. And the third one, cybersecurity, in which we are teaching our kids and teenagers. Before we will show an examples, I want to give a little disclaimer. We are going to talk about a couple of examples, but we are not saying that or recommending each one of them. At first, let's start with academia. There is a growing understanding in academia for the need of cybersecurity capabilities. Because of that, we can see that there are new cybersecurity master programs that are being created. For example, you can see different programs from Europe. Here you can see an example from Israel, an MSc program from the Ben-Gurion University from the south. You can see another example when the screen is not flickering from Oxford. You can see another example from the University of York. And one of the problems is that teenagers are not relevant for those specific programs because most of them don't have their masters yet. Of course, that understanding in academia is not relevant only for Europe. It's only relevant for other places. Here you can see a paper that was published on 2017, which shows 61 programs of cybersecurity across the globe, across 17 different countries. And of course, there are many more. If we are talking about industry, most of the education in industry is focused around certifications. We have certifications which are focused on hands-on experience. We have certifications which are focused on policy, which are focused about knowledge. Here you can see another example of those certifications, and of course, it's only a partial list of that. Again, when thinking about teenagers, we can understand that there are mainly two limitations between them and those certifications. First of all is the cost. Second, there are certifications in which you need experience in the industry to apply for them. And another shift that is being conducted as part of the educational landscape is the hybrid between academia and industry. Here you can see an example in which you can turn your certification into a degree. You can use those certification and transfer credit. But when we are talking about teenagers, what we are teaching them? Mostly safe internet, privacy controls, awareness, password safety, social media safety. But what about network threats? What about denial of service, for example? What about IP spoofing? What about code vulnerabilities, buffer overflows, SQL injections, quoted scriptings, and others? If you think about it, a lot of teenagers are developing today applications for mobile, web apps, but they don't have the basic understanding of those specific threats. And why? Because we are not teaching them that.
So now we'll try to define the problem, or the three main problems we see from this perspective. So let's start with the unskilled workforce. How can it be that none of the top 10 US computer science programs even require a cybersecurity course for graduation? More than that, 3 of those top 10 US computer science programs, which may be also some of the best programs in the world globally, don't even offer an elective course in cybersecurity. What does that mean if not these 10 US universities don't think that students should even learn cybersecurity? The results of that we can see in what what security leaders around the industry say. They say that 77% of them think that the educational system does not prepare does not fully prepare cybersecurity professionals for the industry. This results in that fewer than 1 in 4 candidates are found qualified for a cybersecurity position. Now, if we look at the limitation of the educational system, we can see that the main things are that the lack of experience in complex projects and real-world technologies are the main reason why they are not found qualified later on when they try to find a career. How many of these students even learn source control or cloud technologies or containers or understanding the risks in every one of these real-world technologies? Students, when they are not getting the right education of cybersecurity, they're not understanding later on. When they apply for a real world in the industry, they're not understanding the security risk behind it. And if we look at the characteristics of the security expert, we see that they lack all of them. Technical knowledge they don't have because they didn't get the right course or right education. They're not thinking about out of the box because they don't know about what to think. They never even been familiar with cybersecurity. And adversarial thinking is something that they can't even think about because they weren't ever exposed to that topic. Another limitation of the educational system is that the teenagers, as Shlomi showed earlier, teenager cybersecurity education is mostly focused around internet safety. It's not uncommon to find in Israel teenagers who are being taught in school about internet safety, about privacy controls, but they still don't control their privacy, not in Facebook, not in Instagram. They don't care about it, and they are not really understanding it. The real reason behind that, even thought they are taught about it, is that they are not really understanding the reason why they need to be afraid from these threats, why they need to be afraid from these risks, why they need to protect themselves from these risks. So we need I will show later the solutions, but kids and teenagers are not exposed to real technical matters in the cybersecurity education. And another big problem is women in tech. So how can it be, again, that 74% of girls in middle school express interest in science, in technology, in engineering, and in math, but only a couple of years later, in high school, when they need to choose their college major, only 0.4% of them choose computer science. That's very awful numbers. Okay, another thing is that even with the increased growth of 15 to 20% in the past, today, and in the upcoming years, of cybersecurity positions and jobs and computer science in general, still the vast majority of computer science jobs will be pursued and fulfilled by men. Okay, you may say, now this is the situation, but we are working on it, and soon many women will be learning and getting the college degree or a university degree on computer science. But as you can see, hopefully on this presentation, 37% of them, of the computer science graduates 30 years ago, were women. Today, in 2015, this number has been decreased twice to 18%. Now, if we look at the situation in cybersecurity, we can see that the situation is a little bit better. 20% of the global cybersecurity workforce is occupied by women, but it still means that only 1 out of 5 workers in cybersecurity industry are women, which is, again, very bad. If we try to understand the reason behind that, or if we can see something little bit negative from this perspective, we see that only 13% of the Fortune 500 leaders of cybersecurity, even though 20% of them working in the industry are women, yes, but 13% of the Fortune 500 leaders are female. Now, if we try to understand the reasons why girls are not choosing computer science, we can maybe can see that when they look at the industry, when they look at the leaders, the people that lead the community and they lead the industry, they see no inspiration there. They see that they cannot be there as them because women are not a majority there.
So after talking about the problem and of course the growing need for cybersecurity experts, let's try to think about a solution. Recall that we saw this presentation before. What we are saying, and our proposed solution says the following: in order to improve the situation and create the next generation of cybersecurity experts, we need to wrap each one of the phases in the educational system with relevant programs which are focused on cybersecurity among teenagers. Here you can see an implementation of such suggestion and how it's conducted in Israel. First of all, I will say each of one of those programs is a great program. It will take us more than one presentation to go over each one of them. Because of that, I urge you, first, read the white paper in which we detail more. Second, also you can surf to the website of each one of them with the links you are seeing here. I will give only a slight example on each one of them. Let's start with Pixels, a program which is targeting the 6th grade students. And the goal is to give introduction to technology. What is technology? Connect the young students with the new technologies which are rising. The second one, StarTech, which is focused on from 7th to 9th grade students. And the goal of that program is to give an introduction to programming. For example, the students there are developing computer games. The next step is a program in Israel called Makshimim, which is the national cyber education program in Israel. In that program, students are learning twice a week, after school hours, by the way. Every session is about 3 hours, and the main goal is to create the next generation of security personnel in Israel. In that specific program, The students are learning networking, operating systems, security threats, and others. One of the biggest things that is being conducted in that specific programs is that the students are creating real-world projects with mentors from the industry. Those three programs are operated by the Cyber Education Center in Israel. And of course, with a lot of partners. Again, I encourage you to go over and read more information about those programs. The last program that I want to talk about is the Odyssea program, also known as the Future Scientist program. The program was created based on the vision of the late Prime Minister and President of Israel, Mr. Shimon Peres. The goal of the program is to nurture the next generation of scientists in Israel. One of the majors in that specific program is cybersecurity. The goal is to connect between formal education from academia. Those specific kids are starting to learn in university. And as you can see, the program started the 8th grade. They are learning calculus, discrete mathematics, linear algebra. And in parallel, they are also learning and having hands-on experience in cybersecurity. Because the combination between them and all of those that learn linear algebra, the linear combination between all of them is very important. And thus we get, from one hand, the academia, and from the second hand, the practical experience, and of course, with the connection of the industry. That specific program is operated by the Maimonides Fund Center for Future Scientists. Again, all of those programs are being conducted between and are part of a general initiative in Israel that connects industry, academia, volunteers, and more to create the next generation of cybersecurity experts. And that's not enough. One of the problems that Nachman stated before was the lack of women in the industry. Because of that, there are two main initiatives in Israel which are focused on that. The first one is Cyber Girls, which is a community that focuses on technology, computer, and cyber, and connects between young girls and women from the industry. They have hackathons together. They have someone to talk with about their inspirations. Also, a project that was started a couple of months ago. In Hebrew, it's called Project Me'amemet. In English, if I would try to translate that, the project of You Are Amazing. And the goal is to create a curriculum which is focused on girls to encourage them to select science and technology as a course of study. One of the things that are also being conducted is to find inspirations and to create some kind of an inspiration for excellence among youth in Israel. For that, there are different competitions in computer science, cybersecurity that are conducted. Here you can see only a couple of examples of them. Again, I encourage you to read the white paper for more information, and I will go into give a little example of part of them. The first one, called Code Guru, is a math and computer competition. The competition was founded on 2000. Until now, there was about 19 competitions, and it's mostly based on those questions. Here you can see an image from one of the contests. Code Guru Extreme, which is based on Core Wars, in which we have survivors written in assembly. One of the goals of the competitions is not only to encourage excellence, it's also to open the minds of teenagers to information and curriculum that they didn't thought before. For example, most of teenagers are not learning assembly. Java, .NET, and others are much more easy. And because of that, there are specific things that we are doing. And when I'm saying doing, it's not we, it's the community in Israel, the industry in Israel, the government in Israel, to encourage those things. Since 2015, there is a competition in Israel called Skills Coding. You can think about it like the Olympics of cybersecurity in Israel. It is based on gamification. We have code versus code. The specific competition is being managed and operated by the Ministry of Education. Each one of the teams has a mentor. So here we can see another collaboration between the government, the Ministry of Education, and industry, which delivers those specific mentors to help the young teams, from high schools, by the way, to understand how to develop code, how to express their skills among a group, to develop soft skills. Here you can see a couple of examples of the gamification. One thing which is very interesting in that program is that the winners of a specific year are becoming the development team of the competition for the next year. You can see that we also want, as a community in Israel, to develop and to help create role models for other kids. And all of those could be also kids, not only people from the industry. Here you can see also the supported language that are part of that specific competition. So if we will try to sum up, what are the basic building blocks of our new educational approach? First of all, teach technology. Don't stay only in internet safety. Don't think that those specific kids can get deeper understanding of technologies. Mentor them while they are doing real-world projects. And we will show examples of those specific projects. Encourage excellence. It could be in the course of mentoring. It could be in the course of competitions. Give them internship in high-tech companies and big corporations. So we talked a little bit about what we want the kids to do. So let's see a couple of examples. Of course, again, it's only a short list of examples of things that kids can do. Here there is a project which its main goal was to create a CFG, a control flow graph in Linux from binary files with no source code. That specific project was conducted by 14 and 15 years old kids. I have to say, after being a lot of time in industry, not a lot of people in industry can say what is CFG and what is ELF. But if you think about it, kids can do a lot of things. Here they took the binary file, disassembled them, identified basic blocks like function perilogs and jumps and calls, created a visualization of the application, and used that to identify part of the application based on previous analysis. For example, encryption methods. For example, sorting algorithms. Another example is the network mapping application, in which kids, again, for 14 and 15 years old, created an application that leveraged passive and active fingerprints to identify operating system. And of course, most of the things that they did was to research other things that were already done. For example, other attacks in DEF CON, Black Hat, and others. Based on that, they create that specific visualization. And here you can see that every orange circle is Linux, every blue circle is Windows. And that's not all. There are many more projects. The thing which is the most interesting here are not the name of the projects, which probably have some sense. Not the description, but the age. And also we had specific groups which were girls only. And the connection, by the way, between the age of the participant and the goal of the projects, at the beginning, we thought we can't achieve that. But if you think about it, 15 and 16 years, boys and girls, created applications for anomaly detection based on machine learning, sandbox implementation, syscall analysis, and others. And of course, there are many more projects. But the goals of the projects is not only to do the projects, but also to learn new technology aspects. But not only that, we also want to create and nurture the soft skills. And because of that, you can see that one of the things that those kids learn as part of doing the real world project was collaboration, and of course other technical aspects in which you can read.
Now, MACTF 2017, as you can see, Shlomi presented some of the projects that conducted by teenagers in the formal and informal educational system, but this is even more informal than the informal educational system. So MACTF 2017 was conducted, was organized, I think 1 year ago. It was organized by Noxal, which is a security group I am part of. It was a CTF event organized for Makshimim, which is a program that was presented a couple of slides before that, for graduates of the program of Makshimim, and it was organized by students that are learning, that are currently learning in Makshimim, both in the 11th grade and both in the 12th grade. So what is interesting here is not the event itself. The event itself had challenges in many topics, such as web exploitation, binary exploitation. It was a CTF, yeah, something that most of you are familiar with. But the thing that is interesting here, that in Israel and specifically in this event, we have a great example of how the education system gives the opportunity to teenagers who are currently learning in the same educational system to give and challenge graduates of the same educational system. So these young people in my team had to learn a lot of topics, a lot of interesting attack surfaces, and a lot of different attack techniques in order to create interesting challenges that can challenge people that are graduates of the same program they didn't finish yet. We'll present more about Noxal later.
Okay, so while doing and providing new knowledge to those specific teenager, we saw that there is problem regarding the mental model. If you think about what a decision-making process is composed of, so we have the processing power of our brain, we have the amount of time that we have to decide or to act, we have the information that we have, our knowledge. But because cybersecurity is so complex, there are cases in which an unclear mental model is created. And because of that, we thought, how can we create challenges and tools and pedagogical aspects which enable us to fight those specific cognitive conflicts. And one of the ways that we decided to do that is to leverage what is called conflict-based learning, in which we, by design, create conflicts to enable learning. And let's show a couple of examples for that. First of all, here you can see a challenge that we gave those specific students, in which we took the section of ELF, which is responsible for describing what is the interpreter or the loader, which is needed to load a specific file, and we modify that. While executing the program, of course, it won't be executed as needed. We gave the specific file to our participants. And the goal was to build a mental model how loading is being conducted in the operating system. Because to fix that specific problem, you can't guess. You can't do a brute force, probably. And they needed to understand how the process is operating. The same we did in another challenge, in which, as part of the syscall mechanism, we replaced the syscall opcode with the syswait opcode. And of course, the syscall wasn't called as needed because we changed the opcode. A small change can make a big difference. And because of that, we had the ability to reshape their mental model. After those challenges, and I only showed a couple of examples of them, the students from the 9th and 10th grade had a better understanding of the ELF file format, what's the difference between segments and sections, how system calls really work, how to use a debugger, how to use a disassembler, how to use supporting tools to analyze these binary formats. And we did the same for networking, and we did the same for programming and from others. And we saw that the conflict-based learning is so important to such a domain, which is so complex and has a lot of needed details. Because the conference is being held in Europe and in the UK, we wanted to give a couple of examples what is going on here. Of course, there are also a lot of examples which are from the US and other places, which are not being detailed here. The first one is Teen Tech, which is focused on science, engineering, and technology, and to give young teenagers an understanding what are the opportunities there. They also have the same thing for cybersecurity. You can see a different headlines on the screen, which shows the huge importance that the UK gives to educate those teenagers in cybersecurity. When the screen is not flickering, of course. And another example for that is a specific college that is going to be open probably in 2020 in the UK, by the way, in Bletchley Park. Some kind of a good story for that, in which they are going to nurture the best of the best in cybersecurity in the UK. Of course, there are also other programs, especially in the UK, such as Cyber First, cyber discovery, which we detail here. The main goal is not to give you a detailed explanation of each one of them. It's to give you an understanding that also governments are understanding the importance of that issue.
So now we'll try to present a case study or an example of how you can educate teenagers, or how education of teenagers can be done not through educational systems or not through formal educational system. The example will be an example of mine. I am the founder of Nuxal and I'm part of Nuxal. And I'll try to give you an example or give you a sense of why teenagers, despite their young age, can do whatever they want. And they are not different in any way than adults. So what is Nuxal? Nuxal is a teenager security group. It's a local Israeli group which composed only of local Israeli teenagers. It is composed of only passionate teenagers in cybersecurity and computer science. And we are engaged in the creation and participation of CTFs and spreading of cybersecurity knowledge among our community. We do it by many ways, by conferences, by volunteering lectures, and by other means. So if we try to ID or give a sense of what Nuxal is and how many people are there and such, so it was founded in 2016, 2 years ago, by me and another colleague, which was also my teacher at Makshimim. Another great part at Makshimim that graduates of the same program can teach other students in the program. So he was my teacher, and the number of members in Nuxal are 50 in the global group and another 35 in the CTF group. And the age range is mostly around 17 to 18, but there are some that are 19 and also, I think, already 20. Some of our activities are blogs, as I said, CTF creations. But the two things that I want to mention here is community education, which is very important for us, and CTF creation and participation, which we are currently around top 70 at the CTF time. We'll present later on examples of community education. So the first event we organized was also the first CTF ever organized by teenagers in Israel. It was a group of 5 or 7 very passionate and very passionate teenagers aged 16 to 17 years old. It was created with the support of industry. PayPal helped us out. Community, many communities that are operating in Israel, mostly adult communities, helped it also, and municipality, which sponsored the event and gave prizes. We had there challenges in many topics. Again, web, operating systems, a little bit of porn. And this was our first event. I think 50 people or 40 people participated in that event. Later on, we had the NoxCon, which was our first conference. The idea behind the conference, it wasn't big or something, yes? It's not like Black Hat or something. But the idea behind it is that teenagers are the speakers, and the crowd that listened to these lectures are also teenagers. This conference had 30 people live And online, we also broadcasted it on YouTube, and I think around 1,000 people from Israel, teenagers from Israel, watched the conference. We had many talks, five talks, I think, about different topics such as RSA and vulnerabilities, and even bioinformatics and machine learning. And it was very, very successful. So the next example is community education. So as I said, one of the main goals, one of the main things we think very important is community education. I think that it's not enough to just have knowledge or just to be experienced in projects or real world technologies. It's not enough. You have to also spread the knowledge you have among your colleagues or your community. Especially I was 16 when I founded the group, and now I'm 18. And I think that many of my friends who learned with me in school or in other programs weren't even familiar with the cybersecurity and what is it. So we conducted many events in order to teach and spread it to the community. We created more than 30 programs across all Israel, including through the Tech Sheva Juniors event, Tech Sheva Juniors organization, which helped us out. We had more than 100 lectures and events, which the speaker were teenagers, 16 years old, 15 years old, which is amazing. 3,000 teenagers being exposed to these talks and learn about cybersecurity through them. I am myself an example of the Israeli cybersecurity educational program. I am the graduate of Makshimim. I am the graduate of the great effort in Israel, the great effort doing in Israel in order to evolve these security experts. I've started to work in the industry at PayPal at 16 years old. During my high school time, I founded Noxal during my high school time. And I'm the proof that everything is possible. It's possible if you really want, and if you really want to innovate, if you really want to create something from scratch, you can do it. And it doesn't matter what is your age, if you are 15 years or 16 years old, or if you are 26 or 40. For some of you who are parents, I think this is a message that can be very important for your kids. So another event that we have created is NOC CTF, which was our first online CTF. It was conducted 3 months ago exactly. It was online CTF with many different challenges, many different topics. And we had 900 teams from all around the world. Our first online CTF. The first Israeli team which ever organized a CTF, an online CTF. 4,000 people took part. And this only proves that in 1 year change, you can go from 50 participants in an event that is just an idea to a global event which is a success. So now we'll try to show you how you can participate and help the industry, the community, to solve these problems we showed you here on the presentation. It's about our future thinking, or how we can see you take part in that. So first of all, organize practical learning events. Do CTFs, trainings, competition, and any other idea you have for the community in order to expose those computer science graduates and those teenagers to cybersecurity. Give them the practical experience they need in order to become cybersecurity experts. And another great thing is you need to mentor teenagers. You all are experts. You understand in cybersecurity, you work in the industry, but it's not enough. Try to maybe talk with your school to have one lesson with the 9th graders, 10th graders. Give them a talk about cybersecurity, about the industry, what you do. How do you influence the world? How you change it for the better? And how can they also be part of that? The third thing is help teenager security groups in your community. Sponsor them. Not with money. Give them the place to sit together, learn together, participate in CTFs together, and create stuff by themselves. And the fourth and most important thing is collaborate. Collaborate with the educational system to do 2 things. First is expose teenagers to the industry, and the industry to teenagers. One of the biggest problems we found, and I felt it myself, is that teenagers are not aware what is going on out there in the industry. They have their educational system, they go to school, that's the only thing they know. But later on, when they finish college, there is there is companies, Google, Facebook. And one of the important things is to expose them and show them what is the real world, and that it is not so different from what they're seeing now in their life. And the second thing is expose the industry to teenagers. Give them the opportunity to internship in your companies. Give them the opportunity to work in your companies, to learn from you, to get the right experience that will help them also in 18 or 16 years old to work in the industry.
So basically, here you can see a couple of examples of how can we upgrade our current approach. How can we expose more teenagers? Maybe we will start in first grade and not fifth grade or sixth grade. Let's expose more middle school girls to cybersecurity leaders. Let's teach cutting-edge technology, and of course, let's invest more in the concept in which we teach our children.
So let me summarize the presentation with the Black Hat sound bites. So the first one is, remember those, yes? This is very important. First one is, youth age is the most suitable for education in cybersecurity. As we showed you earlier, in Israel, it's working great. People are starting to work in the industry, are getting the right experience, and are getting the right expertise they need in order to work in the industry and to be real experts. The second thing is a full package education system in cybersecurity for teenagers is the only way, and we can aid, but this is the only way from our perspective to solving the workforce shortage. We have to give them the tools, even when they are teenagers. And the third thing is cooperation, and cooperation. Cooperation between community and industry is the only key to achieving this goal and close this shortage. Remember, 85 million people shortage in 2030.
And maybe we'll sum up with a couple of things which are not only for teenagers.
Yeah.
Most of the talk we talked about teenagers, but let me share with you all something about my late grandfather told me. Make sure you learn something new every day. If you can think about it, a day that you didn't learn anything is a day you wasted. And think about it. You are also role models for your kids. You are role models in the industry. Think how you can evolve every day. For sure, we talked mostly about teenagers, but basically, they are looking up to us. We are the experts that they want to be. And because of that, if we will show them that we learn something new every day, they will want to learn something new every day. So thank you, everyone, for attending our talk. I hope that you won't have any more wasteful days and you will learn something new every day. These are our contact information if you have any more questions. And of course, I think we have 2 more minutes. If someone has any questions, we will be happy to answer them.
Yeah. I think.